All right, let's get right into it. Today, we are taking a deep dive into a really fascinating and I mean potentially revolutionary new paper by Alexander Amaya and Odilon Kosso. They're proposing a completely new unified theory of physics, and honestly, it might just be the key we've been looking for to solve a problem that's been bugging physicists for 100 years. So, the paper kicks off with this incredibly profound question. We've got these two magnificent pillars of modern physics, right? One for the tiny, quantum world, and one for the vast, cosmic scale. They both work perfectly in their own domains, but they don't talk to each other. They're written in different languages. So, what if that's the whole problem? What if we've just been missing the cosmic Rosetta Stone that could translate between them? So here's our roadmap for this little mini lecture. We're going to start with that big, unsolvable problem that's haunted physics for so long. Then we'll introduce this new cosmic language that the paper proposes and see exactly where it all clicks together. After that, the fun really starts as we see how this new tool can crack some of the biggest puzzles out there before we finally zoom out and look at the completely transformed universe this idea describes. For the better part of a century, physics has been living in a divided house. We have these two master theories that together describe pretty much all of reality, but they are completely fundamentally incompatible. You see, on one side of the house, you've got quantum mechanics. This is the wild, weird rulebook for the subatomic world, a world of particles, forces, probabilities, and fundamental uncertainty. Then, on the other side, you have general relativity, Einstein's incredible masterpiece. It describes the grand, elegant cosmic dance of planets, stars, and entire galaxies as a theory of smooth, geometric space-time. Now here's the problem. Try to use them together, say to describe what's happening at the center of a black hole, and the math just breaks. It spits out nonsense, infinities. It just doesn't work. And this is exactly where the paper by Amaya and Kosso comes in with its big, revolutionary idea. They propose that there's a universal transformation principle, a kind of shared grammar that's hiding underneath both of these theories. They call it the delta infinity omicron framework, or delta AF-O. So this new cosmic language is built on just one core concept, the general relativistic principle, or GRP. Now, what is that? It's a meta-structural principle. It reframes reality not as a collection of static things, but as a fundamental process. It describes a transformation that always moves from a discrete, distinct starting point, that's the delta, through some kind of unbounded mediating process, that's the infinity, to a final, bounded, definite outcome, that's the omicron. To help you really get a feel for this, the authors give us this fantastic visual metaphor. I want you to picture this. Imagine a simple triangle. That's our discrete, well-defined starting point, our delta. Now imagine you start adding sides to it. It becomes a square, then a pentagon, a hexagon, and as you add more and more sides, it passes through this infinite series of polygons. That's the transformation process, the omega, until it finally resolves into a perfect, smooth, bounded circle. That's our final outcome, the oma. You see? From something discrete to something whole. And here is the aha moment. This simple structure, it turns out, is hiding in plain sight in the core equations of both theories. Look at quantum mechanics. The wave function, psi, which is basically a cloud of all the possibilities for a particle, transforms through Planck's constant, h bar, which is the fundamental unit of quantum action, into psi squared, which is the definite probability of finding that particle in a specific place. Now look at gravity. The stress energy tensor, T mu, which describes all the matter and energy in a region, transforms through Einstein's constant into g mu, the actual physical curvature of spacetime. Do you see it? A beginning, a process, an end. It's the same pattern, the same cosmic language. Okay, so here's the really crucial point. This isn't just some neat analogy or a philosophical trick. The paper argues that this shared language reveals a deep, profound physical truth at the most fundamental scale of reality, the scale where these two theories absolutely have to unify. This brings us down to the Planck scale, the absolute basement level of reality. And just look at these units. Do you notice something? Every single one is built from the same three universal constants: G from general relativity, C from special relativity, and H from the quantum world. This is no coincidence. This is the universe screaming at us that at this tiny, tiny scale, these forces are all equally important, and any true theory of everything has to work right here. And at this fundamental level, the paper shows something incredible. The transformation isn't governed by separate quantum or gravitational rules anymore. No, instead there is a single, unified parameter that does the job for both. This parameter literally weaves together quantum uncertainty, h, the strength of gravity, g, and the cosmic speed limit, c, into one single value that dictates the rules for everything that happens at that scale. And here it is, the mathematical heart of the paper. It is just so elegant. When you push both theories to their absolute limits, down at the Planck scale, the minimum amount of uncertainty that quantum mechanics allows for becomes exactly equal to the minimum requirement for something to gravitationally collapse into a tiny black hole. The two theories don't just agree here, they become identical. They become one. The math literally resolves to this perfect identity. On to Fermi over 2 is greater than or equal to lambda over 2. It's a checkmate. Okay, so now that we have this unified language, this cosmic Rosetta Stone, what can we do with it? Well, it turns out we can use it to go after some of the most stubborn, intractable puzzles in all of physics. Let's start with black holes. Traditionally, we think of them having an infinitely dense singularity at their center, a point where physics just breaks down. But in the Deleuzian view, you get a finite quantum core with a maximum possible curvature. Why? Well, think about it. If reality is a transformation, it can never hit an infinite dead end. It has to transform into something else. This also solves the famous information paradox. Information isn't destroyed, it's preserved in this core and then gradually released as part of that ongoing cosmic process. This new framework also gives us a whole new origin story for the universe. Forget the Big Bang singularity. Instead, the universe emerges from a pre-existing state of pure quantum geometry. And in this view, spacetime isn't the smooth, continuous sheet we imagine it to be. At the tiniest scales, it's a seething, energetic quantum foam. Even time itself isn't fundamental. It's an emergent property that arises from the dynamics of this universal transformation. I absolutely love this analogy the paper uses to explain how it avoids singularities. It's like a quantum trampoline. Imagine you're compressing spacetime, pushing it down, down, down towards the Planck scale. Instead of breaking and creating an infinite singularity, it gets incredibly stiff. It becomes rigid, resists that compression, and then it bounces back. So we don't have a big bang, we have a quantum bounce. Now, what's so important here is that this isn't just a cool story. The Delta OO framework makes real, concrete, testable predictions. This is what separates a neat idea from actual science. It predicts we could find evidence of a modified uncertainty principle, or that this space-time foam actually affects how light travels across the cosmos. It even suggests we could find corrections to black hole entropy or unique signatures left over in the cosmic microwave background, the afterglow of our universe's birth. So, this entire incredible idea, this whole framework, culminates in a single powerful equation that aims to describe the complete quantum gravitational state of our entire universe. And here it is. Let's just take a second to appreciate this. On the left, you have psi universe, the state of the whole universe. And on the right, you have T, the engine of transformation, powered by our unified parameter, acting on a single state that fundamentally links quantum possibility and gravitational geometry. Now, that little dot symbol is the real magic here. It doesn't mean add or multiply. It means these two things, the quantum and the gravitational, are entangled. They're inseparable parts of a single reality. The universe isn't a bunch of stuff happening inside a box. The universe is the transformation. So what's the bottom line? What are the biggest takeaways here? First, that quantum mechanics and general relativity really are just two dialects of the same cosmic language. Second, space-time isn't the fundamental stage for the play. It's an emergent property, a shadow cast by deeper quantum processes. Third, all the forces and constants we observe in nature seem to arise from this one single transformation logic. And finally, maybe the most mind-bending idea of all, reality is a verb, not a noun. It's a process of becoming. And that, of course, leaves us with one last colossal question. If the entire universe, from top to bottom, at its most fundamental level, is a continuous transformation, a process moving from one state to another, then what's the ultimate destination? What are we and everything else transforming into? A question this framework might, one day, actually help us answer.